We finished the computer vision things, so we'll start to talk about deep learning. Last time in the learning 5, we talked until page 23 because that's 3 weeks ago. So I would like to briefly review our work. So from page 13, we have input image, input data. So usually the deep learning include 2 parts. One is for feature extraction. The other is for classification. It's regular, we are doing this way. And you should try to get used to this kind of function. 你要习惯这种 function. Get used to this kind of function. Okay. So in our case, this is the output. This is the loss function. This loss function. And then this is y is the output. F is the entire activation function. F. W is the parameters we want to learn. W include the weight, the bias. So we don't know W. And we know the input data Z. This input, suppose this input image 28 by 28 pixels image. So input is 1. And we combine with and pass through, or actually the linear combination with the weight, W, and bias. And after this one is a linear combination. And then either F is just a linear combination, or F is the activation function, and Y is the output. Okay, so this one there, and the output become the input, and we're next there. Okay, and our final loss function is here. So suppose this function is a suppose they have 16 layers. So we have 16 activation function and softmax finally. And we got output Y. So this term is estimation term. And we don't know W because W is the value, the parameter we want to estimate. Like the Gaussian model, we want to estimate the mean and standard deviation. But here we want to estimate W. W is the weight and the bias for the parameters of network. And this is ground truth. Ground truth. You collect the data, the ground truth. So the output Y, we need to compare with ground truth. And our purpose, if it's a mean square error, we want to minimize this error. Okay. And suppose the total data is n images, the spatial size. So we do the average. But if you use the machine learning and then you put entire images, and the n will be the same. So you ignore the n. So in machine learning, we do sum of square difference, summation, square, and difference. But in deep learning, because we use the batch size. Okay, so we are divided by the number of batch size, become average. Okay. And in the net, they already tell you this term is important. This we call regularization term, like Lagrange, the supportive vector machine. They have a regularization term, sometimes called noise term or constraint term. It's either noise term or constraint term. And recent 2 years, people start to consider this event in this turn。以前大家都没有注意这个 turn， 那事实上这个 turn 非常重要。那最近2年开始就注意到这个，因为 any data usually has a noise. If you don't include this turn, the noise will inside here. If noise include in the input data Z, okay, and your parameters will cause problems. W 会产生这 Sorry about that. Internet problems. So the purpose, we try to find the global minimum, okay, and using the gradient descent method to find the parameters W and B, okay, and this learning rate. So here we would like to introduce for this the net. Okay, we would like to introduce something about convolutional neural network. One we call local receptive fields. Second, shear weight, and third, subsampling. And we use this one instead of full connected because before this one, when we do the recognition, we use the image and input to the NLP or neural network. Use the original image that we call raw data and input to the neural network and for the classification. And here difference is that before we input, we can see this one. Before this one, okay, people do it here. They use a neural network and this MLP. So 1 layer, 2 layer, 3 layers. So input the raw data here. This input data to here and output. In this example, we try to recognize, or we call classification 0, 1, 2, 3 until 9. Okay. But here he feel, oh, that's not good enough. So he think about if we can extract here, we can extract more important information we call features, and then input to here, and probably the result will be better. So he is correct. So that's the beginning for the initial for the deep learning. So based on original data, they do the extraction. 1 layer, 2 layers. So from only one gray value image become here 16 feature map. 16 feature map from one after extract, and here's 16 features like edge detection, and then input to here. Okay, so the result is better. And this process is similar to edge detection, so it's convolution. So they do the convolution, use 3x3, 4x4, or 7x7 filters to do the extraction. Extraction important features. Okay, so the important is the field, the parameters. So when you do the Sobol filters, the parameters are designed by people. But here, the parameters are by learning, using by learning. Okay, so back to here. So we talk about, so here in page 20, so instead of traditional fully connected neural network, the last 3 layers, the name field, okay, we can do convolutional neural network instead of connected neural network. 这两个不一样哦，这是 convolutional neural network， 这是 connective neural network， 不一样。这 convolution meaning we have filters. Connected It means fully connected is all connect without filters. So first one, you think about, we should consider the local receptive field. What's a local receptive field? So instead of input entire image, we want to extract more detailed information. So they use a small window. Again, it's like a high pass filter. So this is 3x3, 5x5, 7x7 filters, but right now most of cases is a 3x3. They try to use these parameters by learning. So this is this one to extract the local features. So extract the local features we call local receptive field. Okay. And for the other example is like this case. Okay. If you want to extract this one based on different filter parameters, so different parameters will extract different information. Like this one, they can extract the boundary. Here, they extract some like a top, and this is some intersection and the lower. Okay, and this extract the middle one. Okay. Extract both sides. Like this look like the vertical filter. This look like horizontal filters. This look like the corner filters. This look like the boundary. So many different kind of filters, they have their own purpose to extract the information. So this one we call local receptive fields by using different local filters. Okay. The second one is shear weights. The purpose for shear weight is reduce the number of parameters, okay, because the concept is convolution. So after the small window, we extract one and we shift 1 or 2 pixels. We call stride, and do the extraction, do the convolution, and shift 1 or 2 pixels and do the convolution again. And from top until the bottom right, do the scan line. So if we see here, for example, this is only 1D. The filter, remember, the filter parameters are by learning. It's learning. The one I find, what's the shear weight? It's meaning original. Suppose this is a 2x2. Okay, sorry, this is 3x3. But for our example, in this example, easy one, your input is 1D, so the value is 2134, 2134. Output, we do not have an output yet. So we to learn the filter, this one. Okay. And what I write here, it means each time the filter in the beginning, to the first 2 pixels, and they extract. Suppose they learn the filter is like 1, 2, 1, 0, and they got a 2 here. And you shift 1 stride, shift 1 pixel, and got the other one, because this 1 plus 0, 3 will be 1, and 3 plus 0 times 4 will become 3. So this will be your output. So your filter value will be 1, 0, only one filter. But here I'm not sure, but they say here, what's the shear weight? When you learn this one in original, this one is to shift. In original, this parameter are not the same. So after they do the shift, and then suppose they shift 3 times, and they got the average value of 3 value, average value of this 0 value, and it's become the filter parameters. 它这里有讲 但是这个我还不确定。什么叫 share weight？ 它意思是说，当你用一个假设这个输入是4:1的影像，那输出就3，因为它没有那个 padding 嘛，好，我们来看这个。那这个来讲的话，它意思是说，事实上你这样 shift 用照这样像 scanline 这样 shift， 实际上你这个 learning 这个值不是1、0，是接近1或0。你再 shift 一次，这个新的值跟这个值会不一样，同个 filter 哦，但是你每次位置这个值都有稍微一点点变化。那如果这样做的话，变成是有这个很简单 case， 变成有3组参数。那对面跟你说你不要这样做，他会帮你做什么？当你这个 scanline 这样扫过以后，他会把这个第一个值全部加起来除以总数变平均值，那平均值就是1，这是最后的 filter 的值。第二个值也是把这3个值加起来除以平均，就变成0。所以他说这个 filter 里面的参数值，事实上是这样 shift 下来以后，因为是同个 filter 的平均值，那大家都共用这个平均值，我们称为 share weight。他是讲是这个概念，实际上是不是这个概念我不清楚。那程式是帮你写，我只是跟你讲说 share weight 的概念是这样子，但是这参数的值是差不多哦，不会差很大，这样子啊。好，那我们现在就不管这个，我们现在就是说 ，OK， 那我每一个 filter 做完 scanline， 它就是一组参数而已，这样子。那一组参数对应一个 feature map， one set of parameters corresponding to one feature map. So this is called share weight. The third one, for the contribution of the net， 就这篇 paper 的贡献什么 ？They do the downsampling. Why we want to do downsampling? Because this one, our filter size is the same, 3x3 or 5x5, but in the higher resolution, you only consider local information. However, you want to consider global information. It's global. So what you can do is two types. One is you can become bigger filter size. So suppose they were 10x10. So you can include entire head. But if you increase the filter size, you increase the number of parameters. That's no good. So in order to reduce the number of parameters, usually we do downsampling and keep the same size of filters. Okay, so in the higher resolution, the same window size, filter window size, you can extract, for example, just small mouse. But when you do the downsampling here, you can include the entire head. And you downsampling again can include even half of the body or tails. Okay, so that's why we want to do downsampling. So that's in the higher resolution, they can extract the local information. In the lower resolution, they can extract the global information, the subsampling. Okay. So we start to talk about the network, the architecture. So the input image size is 32 by 32, for example. But let's know it should be 0, 1, 2, 3 until 9. Okay, not ABC. And the output here, because we have 10 classes, 0, 1, 2, 3 until 9. So we have 10, the output will be 10 cell. Okay, and they divided two parts. The first part we call feature extraction, or we call encoder, or we call backbone. Okay, and the second part is or second stage is a classification using NLP, the traditional neural network. Okay, so we'll introduce this one. And here, remember, for the how many layers for this one? Actually, only 2 layers. 1 layer, 2 layers. We don't count the downsampling to be 1 layer. There's 1 downsampling here, second downsampling here. We won't count downsampling to be the layer. So back to here. Okay. So here, what is this? This original 32 by 32 because it's gray value, so it's only 1 channel. Okay. The filter size, because this is older paper, so filter size is 5 by 5. Right now, people use 3 by 3. So suppose it use 5 by 5. So that's meaning each 5 by 5 input, and it will become only 1 pixel output, the filter result. Okay. And second is the size is 32 by 32. They don't use padding. 它外面没有补连，没有 padding. So the 5 by 5 will start from inside here and shift. So they will lose the boundary information because filter size is 5 by 5. So they will lose 2 pixels in the boundary. 因为它是5乘5嘛，所以中心点为主的话，它上面有中心，对不起，它没有做 padding， 所以它是从内部5个 pixel 开始，所以它损失要 lose 2 pixels in each side. So 2 pixels here, 2 pixels here, total they lose 4 pixels. So the image size from 32 will become 28. Okay, but if they do the padding, they can keep the same size. This first one, the padding problems. Okay, the second is the original have only 1 channel. Here become 6 channel. That's meaning they have 6 filters to extract the information. So each filter do the scan line, they will extract 1 feature map. 6 different filters will extract 6 feature maps. So this one called feature map. Feature maps actually is also images. We won't call image, we call feature map. Okay. So after the first layer by 5 by 5 filters, okay, they create 6 feature map. Each feature map, the size of each feature map is 28 by 28. Okay, and then they do downsampling. So downsampling, they use 2 by 2 pooling. And pooling has several kinds of pooling. The famous one is the maximal pooling, meaning 4 pixels pick out the maximal one, maximal result, maximal value. The second is the average. 4 pixels, they got result, 4 value, and do the average, become the downsampling. Which one is better? Because we want to extract important feature. So important features usually is a higher value, like edge detection. Okay, so we use the maximal pooling right now. So after the downsampling, the size, the image size or feature map size will from 28 become half, 14 by 14. And the number of feature maps will keep the same, 6. So this is become only 1 layer and 1 set. 这样一组哦，这样一组，所以 size 变这样子。好，那 after this one, we do the second filter, the second feature extraction here. Okay. And second feature extraction, The window size is still 5 by 5. And right now, image size is 14 by 14. And filter is 5 by 5. Okay. So they will lose the boundary information, 2 pixels for each boundary. So from 14 by 14 will become 10 by 10. 会变10乘10。好，10乘10。And then we talk about, we want to talk crossover filter. I continue. I want to talk about here is this one. So I keep before I mention about this one, we go to next page. Next page is just a equation. So this input gray value or input feature map value, and this is a weight for each connection, the weight, and this bias is a threshold. Okay, and you do summation, and do activation function, and get the output. So F is the activation function. Okay, so like this one. So they assume this one is this one. So linear combination, if the value bigger than threshold, this bias, so bigger than threshold, so they will classify to 1, otherwise classify to 0. But before you do classification, this won't be 1, this will be value, some value. So like here. That's the gray value. But right now, people use the RGB image. So if you use gray value, each image is only 1 channel, and then your filter suppose 3 by 3, and there will be 9 parameters. However, if your case is 3 channel, for example, RGB, your filter size will be 3 by 3 for 1 channel. Cross the other 3 channels, become 27 filters. 这个很重要哈，这个很重要。就是当你的 channel 是三个 channel 的时候，我们通常 paper 都会跟你讲，哎，我现在用3乘3的 filter 来做，所以参数有3乘3 9个，不对，它是3乘3一起做，哎，3乘3 cross RGB 3个 channel 一起做，所以你每个 filter 是3乘3再乘3个 channel， 这是一个 filter。所以你的 filter 的参数事实上是27个，有 cross over 这个概念，所以3乘3 cross 3个 channel 这样子，这是27个参数，这不要误会了，不是3乘3，它是一起做的。能不能分开做？就后面有不同演算法，它会帮你做分开的动作。啊，那我们现在这里先不谈那些加速方法。我们这里先假设，也就是变成，只要这有3个 channel， 就你的参数会变成 2D 再乘上另外一个。那这里我们不讲 3D， we won't call 3D because they have a 3D filters. But 3D filters, for example, if this is 3D, 3 channel, so the image size will be what? Will be 3 by 3 by 3, that's 3D, and times the total number of channel. 你如果是这不叫 3D 哦，这是 2D 乘上 channel 个数，因为有 3D 的很多 3D 的例子，它变成 x 乘 y 乘 z 以后，再乘上 channel 个数，有类似 4D， 但是我们通常不叫 4D 了，我们还是讲 3D 这样子。啊，这个叫 2D， 那是注意一下，不要那个参数不要误会了。好 ，so this first filter, the parameters like this way, and the second filter parameters like this way. OK， 好，那这我刚刚讲完了哈，我们再继续讲。这是一个例子哈， 一个例子在教你，就是说 ，suppose your filter is 3 by 3 and the parameters is a 1, 0, 1. Just that's this one. Diagonal in the cross diagonal, the cross mark is 1. Other parameter is 0. And so you each time you do linear combination. Convolution is each time linear combination and shift, linear combination shift. Okay, so that this result output become 4, 3, 4. This output result. And so this is the final result. So this final result. So 1 3 by 3 filters cross convolution with the one image, so become smaller feature map like this one. So the same example, if input image is this one, my student do this way. So after they do the 6 feature output 6 feature map, will do like this way. 这是最后6张 feature map 看起来是这样子，那表示它有6个 filter 来萃取不同的资讯，这样子。那我们是试着了解，那时候很早前我们是试着了解，因为我们要改变演算法，我们是试着了解，就这样看完还是不了解，只知道它是有萃取不同的资讯，但是不了解它到底在萃取什么，这样子。好，那有很早前多 paper 在探讨这些问题哦，最近比较没看到。We continue. About output, the output size you don't need to remember. This paper have an equation tell you how to count the output length. 就是这个长宽 You don't need to learn this one. For example, this 3 by 3 and this filter is 2 by 2. Okay, so what's output? So usually, if it's no padding, that's meaning you will lose the boundary information. And boundary information is the half size of the filter. If you have a padding, you will keep the same size. 就这样子啊 ，OK， 那这个东西就帮你画成用这种方式。This is a 2D, but in your Python, Python they already write in the 1D for you, and they do a shift. So that suppose that this input is 2 4 1 0, so 2 4 and 1 0 here. They skip 5. So this based on this 4 pixel and this filter parameters 1 0 0 1, and they got a result. So the result will be 0. So final result 0 4 1 2 0 4 1 2. So in your code, okay, the Python they'll write this format for you. Even so, in your mind, your brain, you think about it's 2D convolution. In the source code, they write 1D, but you don't need to care about this one. They'll do for you. Okay. And this is an example. It's the original image. And after convolution, this output result. And what's the maxima pooling? Maxima pooling is suppose the maxima pooling is 2 by 2 pooling size. So that's meaning every 2 by 2, they pick up the maxima value. So this maxima value minus 1. This maxima value will be 1. This maxima value will be 0. So put 0. This maxima value will be 3. Okay. The same with the second filter and this maxima value. So this will become feature map. The other feature map. Okay, so 2 feature maps. And let's talk about whether you have padding or not padding. We already talked about this one, so we keep going. Okay. So after the first one, the first one. So here again, the concept is that we just mentioned. This one. The concept will include local receptive field. That's meaning small window. we use share weight, or they do scan line, and finally they do average, become the parameters of filters. They do right now we will do downsampling. Back to here. So they do downsampling here. Okay, so this is one layer. And in the net 5, the net 5 is meaning they have a 2 plus 3. 2 layers plus 3 neural network. So the net 5 is equal to the net 2 plus 3. There were 3 neural network, 3 layers of neural network, 2 layers. And then XNet have a 5 plus 3. So they have XNet for next one, XNet. So they have 5 layers. Okay. VGG16 have a 13 plus 3. They have 13 layers, 3 neural network. Okay. So back to here. So what's the next one? So after you do downsampling, okay, and next one we will do convolution again. So then I think about, right now I have a 16 feature maps, and how can I do convolution? They will think about crossover. It's meaning the filter, if the filter consider, suppose 0 to map, feature map 0 to feature map 15. So this one, this feature map number 0, number 1, number 2 until number 15. And this is this feature number. Okay, this feature number here. Okay, and this one. Let me check. Oh, sorry, I'm wrong. Okay, right now up to here. So we have a 6 feature map. 6 feature map. So 6 feature map here. 0, 1, 2, 3, 4, 5. This feature maps here. So this one. And he want to design. He want to use 16 feature filters to create 16 feature map. 他这有已经有做6个了嘛，6个 feature map， 他希望输出16个 feature map 出来。那他开始设计这个。你的输入是6张 feature map， 你的输出他希望输出16张 feature maps， 这是你自己决定的。输入跟输出 feature map 各是你自己决定的。那他为什么？他在讲他为什么要输出这16个 feature maps？ 他这里有讲，然后他跟你讲我怎么设计的，这样子。好 ，So we take a break. We'll continue to talk about. And this is important. Take a break.